Hi, Assalamualaikum. This is a tutorial video basically. It's for chapter 4, but you will need to have a very firm basic that you have learned in chapter 2 and also chapter 3. Okay? Jadi sebab benda ni ada tutorial, it's an informal, I will talk in bahasa rojak, campur-campur. Okay? So I hope you have enjoyed my music, my intro. Okay, memang saja letak panjang-panjang sikit. Boleh semoga terhibur. Alright, before we start to crack our head, because I think this topic is quite hard for students to understand. Okay, but sit back and relax. Hopefully, try to understand the tutorial video. So before we start, I would like to recap our previous video, the graded doping punya video. Okay, so in that video, we ended that there is a concept of Fermi level. Fermi level must be constant. Maksudnya, Fermi level ni kalau kita lukis, we must make sure that the Fermi level tak ada slope. So, and another thing is that the Venn diagram can be drawn in such a way that other slopes, other levels can have slope except Fermi level. So Fermi level sahaja yang tidak boleh ada slope. Yang selain daripada Fermi level, for example, the conduction band, the valence band, and also the acceptor level or even the vacuum level, semuanya boleh ada slope. Okay, the reason why Fermi level tak boleh ada slope, you have to tengok balik in the first video, okay, ataupun in the second video dekat graded doping tu, I have explained quite detail on why Fermi level tak boleh ada slope and yang energy level yang lain boleh ada slope. Okay, so before I can explain to you on the non-homogeneous semiconductor punya Venn diagram, I still have to actually make sure that you remember on how the Venn diagram for homogeneous semiconductor looks like. Okay, hopefully you are by now macam nak muntah dah tengok, dah memang familiar sangat-sangat dah, tidur pun memang mimpi keluar punya lah. So, but for the sake of those who are still not familiar, I will explain briefly on the homogeneous semiconductor punya Venn diagram di sini. Okay, jadi homogeneous semiconductor ni pun kalau nak kena explain balik, saya rasa kita kena start semester baru. And homogeneous, kita kena assume that the doping level is uniform, okay, or dia adalah intrinsic semiconductor. So the first figure here, figure A, this is for an intrinsic semiconductor punya Venn diagram. You have conduction band and then Fermi level overlapping dengan intrinsic Fermi level. So kita lukis EF saja di tengah-tengah and we have valence band. And intrinsic semiconductor ni, you must make sure that the Fermi level is exactly in the middle of EC and also EV in such a way that kalau sini kita ada band gap, so yang Fermi level ni is actually EG/2. Okay, that is intrinsic semiconductor. Untuk B, for N-type semiconductor, you will have EC, and then EF, and then EI, and EV. Okay, for N-type, because there are a lot of electrons dalam N-type semiconductor ni, so the electrons energy is high. Okay, so bila electron energy is high, your Fermi level is always higher than your intrinsic Fermi level. Okay, maksudnya EF is in between EC and EI. Okay, EI must always be EG/2. And then you will have your P-type semiconductor. P-type semiconductor, you have EC, EI, EF, and EV. Your EF mestilah di bawah EI because now your electron energy adalah rendah because now it is P-type. P-type lebih banyak holes. Okay, so Fermi level adalah di antara EI and EV. Fermi level adalah di bawah. Please be familiar with that, okay? The next concept that I want you to be familiar with is the position of Fermi level with regards to the doping concentration. Maksudnya, the Fermi level is actually showing betapa tinggi ataupun berapa rendahnya your doping concentration. So we look at this example. Yang dekat atas ni, I hope you know this is N-type. Okay, N-type. So because we have EF is above EI. Okay, and kalau kita bandingkan gambar yang belah kanan, walaupun dia EF adalah atas EI juga, dengan yang belah kiri, EF atas juga EI, but EF yang belah kanan is very close to conduction band. Okay, and EF yang belah kiri is further from the conduction band. So, untuk ini, since our Fermi level is showing the energy of electrons, so you have to remember that, always remember Fermi level is showing the electron energy. Jadi, menunjukkan yang belah kanan ni, there are a lot of, the energy of electron is very high. Maksudnya, ada banyak elektron yang di belah kanan. This is for high electrons concentration punya doping, punya Venn diagram. And compare yang belah kiri, since your EF ni jauh sikit daripada EC, this shows that electron energy is lower. Maksudnya, sini adalah kurang elektron berbanding dengan yang belah kanan. So, untuk N-type, okay, kalau untuk N-type, EF yang lebih dekat dengan EC membawa maksud doping concentration untuk N-type-nya adalah tinggi. Kalau EF jauh daripada EC membawa maksud yang concentration of N-type doping dia adalah rendah. And for P-type, sama juga konsep dia macam N-type. Okay, dua-dua kanan dan kiri, the EF is lower than EI because this is P-type. So, kalau di belah kanan, you see that EF is much lower, hampir sangat dekat dengan EV. It's very near to EV. Yang di belah kiri ni, EF and EV, jauh sikit. Okay, so this shows that yang belah kanan ni, still EF masih lagi menunjukkan elektron punya energy. Maksudnya yang belah kanan ni elektron dia sangat sikit. So bila elektron sangat sikit, that means holes sangat banyak. Okay, so bila holes sangat banyak, your Fermi level is very low. It is very near to the valence band. Okay, so the concept is, if the Fermi level is nearer to valence band, your P-type doping concentration is high. If the Fermi level is quite further, maksudnya ada jarak sikit daripada EV, then your P-type concentration is low. So, yang senang nak ingat adalah, kalau EF dekat dengan EC, high N-type concentration. Kalau EF dekat dengan EV, high P-type concentration. Asalkan EF ni dekat dengan sama ada conduction band ataupun valence band, the doping concentration accordingly is high. Kalau EF ni dia lebih rapat kepada EI, the doping concentration is low. Okay, so we move on to non-homogeneous. Yang tadi tu semuanya homogeneous semiconductor punya Venn diagram. So you nampak yang tadi tu semuanya lurus-lurus belaka. So untuk non-homogeneous semiconductor, we have discussed apa yang dimaksudkan dengan non-homogeneous. Okay, non-homogeneous ni from the two videos previously, katalah kita ada satu bar of semiconductor, and dekat belah kiri ni kita masukkan banyak P-type doping. Okay, and belah kanan ni sedikit. So bila macam tu, kita boleh lukis graph. Okay, kita lukis graph ni according to the fenomena yang ada pada silicon bar ni. Jadi kita ambil X, paksi Y, paksi X adalah position. Kita ambil sama dengan yang dalam graph ni. Dan part CY kita adalah doping concentration. So pada X yang ini, kita punya doping concentration is high. Okay, so pada X yang hujung belah kanan ni, kita punya doping concentration is low. So how to translate this bar of silicon to the graph? I hope you understand lah. It's just for the sake of understanding. Kita ambil part C X ni adalah position. Mana yang ada lebih banyak concentration, di situlah it is high concentration. And mana yang kita tengok dia kurang concentration, di situlah pada graphnya adalah kurang concentration. So after we have understand on how to draw the graph from the phenomena in the silicon bar, okay, now we have to draw the Venn diagram. So taking into account of what we have learned just now, this part belah kiri ni is high concentration area because tengok dekat graph sini pun dia adalah high concentration. Jadi bila high concentration, that means the Fermi level is nearer to the valence band. Okay, yang teori kita cakap tadi. And on the right, it is a low concentration. So P-type, jadi bila low concentration, maksudnya the Fermi level is further from the valence band. So dia mematuhilah teori yang kita ceritakan dekat slide yang sebelum ni tadi. But unfortunately, gambar ni is wrong. So dalam video saya yang sebelum ni pun saya dah cakap this Fermi level, this Venn diagram is wrong. Okay, why it is wrong? Wrong because the Fermi level should be constant. Kita kena ingat the theory, Fermi level should be constant and Fermi level tidak boleh ada kecerunan. You should not have slope in the Fermi level. So this Venn diagram is wrong. Walaupun teori tentang jarak antara Fermi level and also the valence band is correct. Okay, so how to correct that? Okay, so the correct diagram must obey all the theory. Yang diagram tadi tu, dia hanya obey the theory of the distance between the Fermi level and the valence band. But did not obey the theory that the Fermi level must not have slope. Sebab tadi dia punya Fermi level dia sengit. So, Fermi level must be constant. Jadi dia tidak boleh ada slope. Dia hanyalah garisan lurus yang constant. And since kita nak make sure that the Fermi level punya jarak adalah mematuhi teori, of which kalau dia punya concentration dia adalah tinggi, Fermi levelnya dekat dengan valence band, and at the low concentration area, the Fermi level jauh daripada valence band. So nak tak nak, what we have to do is actually kita slopekan dia. Kita buat supaya the valence band yang ada kecerunan, bukannya Fermi level. So Fermi level kita lukis lurus, but the valence band kita boleh bagi dia ada kecerunan. So to obey that, untuk yang belah kiri, because the concentration is high, make sure the valence band adalah dekat dengan Fermi level, and belah kanan dia punya adalah lower concentration, so your valence band adalah jauh daripada Fermi level. So untuk kita lukis EC pula, you just make sure that your band gap adalah sama. Okay, jadi kecerunan EV mesti sama dengan kecerunan EC. Mesti juga sama dengan kecerunan EA. Selain daripada Fermi level, all other slopes are the same for each levels, right? So this is the correct way to draw your Fermi level if you have a non-homogeneous semiconductor. Okay, so kalau kita letak sebelah-sebelah, you can see very well the difference. Yang salah tu, you see that Fermi level dia yang ada kecerunan. That is your on the left. And yang betul, you can see that Fermi level tu sebenarnya tidak ada kecerunan. Yang level lain tu yang ada kecerunan. Okay. Yang biru bawah-bawah bulat-bulat ni, this is actually the carrier concentration. Disebabkan we are talking about p-type semiconductor. So, kita lukis yang buncit-buncit bawah di sebelah valence band lah. Kalau kita cakap tentang n-type semiconductor, kita akan lukis dekat belah atas untuk conduction band. Okay, so please identify the difference and please don't make the mistakes in your answer ke whatsoever. Right. And I write all this down for you guys to read and to remember the important concepts of how to draw the Venn diagram. So you must always remember that your Venn diagram is actually showing the electron's energy. And electrons at conduction band has the higher energy, electrons at valence band has lower energy, and your Fermi level is showing the electron energy. And the Fermi level must always be constant. Tak boleh langsung ada kecerunan. Okay, in this chapter lah. Kalau nanti dah masuk chapter lain ataupun bila dah masuk postgrad ke, you see that Fermi level ada macam-macam bentuk. You just make sure that yang the concept untuk chapter 4, chapter 3 and chapter 2, Fermi level tidak boleh ada kecerunan. But all other levels are allowed to have slopes. And energy gap must be always maintained. This is the guideline for you to draw all other levels. Maksudnya nanti you have to draw the Fermi level dulu because dia yang tak ada slope. Lepas tu you can draw all other levels yang berkaitan. Jadi untuk kalau contohnya yang material tadi tu yang p-type, selalunya kita akan lukis Fermi level dulu. Lepas tu kita lukis the valence band because we are going to show the doping concentration using the distance between Fermi level and valence band. So kita lukis valence band dan Fermi level dulu. And the guideline to draw the conduction band is by remembering that your EG must always be maintained. Jadi jarak antara EC dan EV kenalah maintain. And then you will have high electron concentration region, EC nearer to EF, lower electron concentration, EC jauh daripada EF, high hole concentration, EV dekat dengan EF, and lower hole concentration, EV jauh daripada EF. Ini saya dah terangkan dekat slide yang awal tadi. Okay, so this video is only for the theory. I will show you another video on how to draw. But before you can draw on your own, you must really understand the theory. So that is the purpose of this tutorial video. So see you in the next video. Alright? Okay, bye.